Hello viewers, in today's session we are going to discuss an important type of indefinite integral in which the integrand is of this form, that is 1 over x raised to 4 plus lambda x square plus 1. So here the integrand is of the form where the numerator is 1 and the denominator is a biquadratic function, that is x raised to 4 plus lambda x square plus 1, where lambda belongs to the set of real numbers, right? So here we'll see whenever we come across with integrands of this type, that is here in the given problem we have to integrate this function, that is dx over x raised to 4 plus 6x square plus 1. So this expression is of this form where lambda is equal to 6, which belongs to the set of real numbers. So in this class we'll see how we can solve these kind of indefinite integrals using the method of substitution, right? So let us first see some important results which we are going to use while solving this type of indefinite integral. So while solving this indefinite integral, we'll make use of these two important identities, that is a minus b whole square and a plus b whole square, right? So let us take this expression, that is x minus 1 over x whole square. So applying this identity to this one, we'll get x square plus 1 over x square and minus 2. Now we can take this negative 2 to this side, so we have x minus 1 over x whole square plus 2, and this is equal to x square plus 1 over x square. And similarly, if we consider x plus 1 over x square, then applying this identity, a plus b whole square will get x square plus 1 over x square plus 2, and taking this 2 to the right, the left hand side, we can write x plus 1 over x square minus 2 is equal to x square plus 1 over x square, right? So these two important expressions we are going to use while integrating this function. And one more important result which we are going to use here is the integral, that is dx over x square plus a square. So here we have 1 over a tan inverse x over a. So this integral is going to be very significant when we integrate this function, that is 1 over x raised to 4 plus 6x square plus 1. So to summarize here, these three important results are going to be used in solving this integral. So let us take this integral as I. So now let us divide the numerator and denominator by x square. So now this integral becomes 1 over x square, and here we have x square plus 6, and here we have 1 over x square, right? So what we have done here, we have divided the numerator and denominator by x square. So now we can write 1 over x square, and here we can combine these two terms together. So we have x square plus 1 over x square, and here we have plus 6, right? So now here one important thing we are going to do is that we are multiplying 1 over x square by 2, and here we are dividing this integral by 2, right? So this 2 and this 2 going to be cancelled. So there is no harm in multiplying 1 over x square by 2 and dividing here by 2. So whenever we have to solve these type of indefinite integrals, so the first step is to divide the numerator and denominator by x square. So now the purpose of dividing the numerator and denominator by x square and then multiplying this term 1 over x square by 2 and dividing by 2 is that this quantity, that is 2 over x square, it can be written as 1 plus 1 over x square and minus 1 minus 1 over x square, right? So now we are going to represent, or we are going to express this quantity 2 over x square as a difference of these two terms. So 2 over x square can be written as 1 plus 1 over x square minus 1 minus 1 over x square, because when we simplify this expression, then this one and this one is going to be cancelled, and 1 over x square plus 1 over x square will give us 2 over x square, right? So now we can write this integral as half, and then 2 over x square can be written as 1 plus 1 over x square and minus 1 minus 1 over x square divided by the denominator, that is x square plus 1 over x square plus 6 dx, right? So whenever we have to integrate functions of this type, the first step is to divide the numerator and denominator by x square, and then we have to multiply 1 over x square by 2 and divide by 2, and then we express 2 over x square like this, that is 2 over x square is equal to 1 plus 1 over x square minus 1 minus 1 over x square. So now the next step is to split this integral as a difference of two integrals, right? So here we'll split this integral at this negative sign, that is we'll write I is equal to half, then we have 1 plus 1 over x square, and here we have dx, in the denominator we have x square plus 1 over x square, and here we have plus 6. So this is the first integral, and the second integral is half, and then we have 1 minus 1 over x square dx, and then we have x square plus 1 over x square plus 6, right? So what we have done here, we have written, or we have expressed this integral I as a difference of two integrals, right? So the first one is half, then we have 1 plus 1 over x square dx and the denominator, then we have half and 1 minus 1 over x square dx and the denominator, right? So let us now call this integral as I1. So here we can write half I1, and here this integral as I2, and we can now write I is equal to half, and we have I1 minus I2. So let us separately calculate I1 and I2. So now to solve I1 and I2, will make use of the method of substitution. So here we have I1. So let us substitute u is equal to x minus 1 over x, right? So when we take u is equal to x minus 1 over x, and if we differentiate both sides with respect to x, then we have du over dx. The derivative of x is 1, and the derivative of 1 over x is minus 1 over x square, that is 1 plus 1 over x square, right? So du is now equal to 1 plus 1 over x square, and here we have dx, right? So for this quantity, we can simply write du, and in the denominator we have x square plus 1 over x square. So we can now use this expression, that is x minus 1 over x square plus 2 is equal to x square plus 1 over x square, right? Because here we are taking u is equal to x minus 1 over x, so we'll now make use of this expression to express x square plus 1 over x square in terms of u. So now here taking x minus 1 over x as u, we can write u square plus 2 is equal to x square plus 1 over x square. So now our integral I1, it takes the form, here we have du, and then in the denominator we can write u square plus 2 plus 6, that is equal to integral du, and this is u square plus 8. So we can now write du, and here we have u square plus 2 root 2 square, right? So now this integral I1, it takes this form, that is integral dx over x square plus a square. Here the variable is u, and the value of a is equal to 2 root 2. So the value of I1 is now equal to 1 over A. A is 2 root 2, and here we have tan inverse x over A. For x we have u, and for A we have 2 root 2. So now replacing u by x minus 1 over x, or x square minus 1 over x, the value of I1 is 1 over 2 root 2, and here we have tan inverse x square minus 1 over 2x times square root of 2, right? So this is the value of I1. So now let us calculate the value of I2. Now here we have 1 minus 1 over x square dx in the numerator. So let us substitute here v is equal to x plus 1 over x. So if we differentiate v with respect to x, we have dv over dx is equal to 1, and the derivative of 1 over x is minus 1 over x square. So from here we can write dv is equal to 1 minus 1 over x square and dx, right? And when we have v is equal to x plus 1 over x, we can make use of this result, that is x plus 1 over x is v. So here we have v square minus 2 is equal to x square plus 1 over x square. So in this case, x square plus 1 over x square can be replaced by v square minus 2. So now I2 takes the form in terms of v, as here we have dv simply for 1 minus 1 over x square dx, and in the denominator we can write v square minus 2 plus 6. So let us simplify it. So we have dv, and here we have v square plus 4, that is 6 minus 2 is 4. So here we have dv and v square plus 2 square. So again this integral I2 is also of this form, that is integral dx over x square plus a square. The value of a is 2, right? So the value of this integral is now equal to 1 over a is 2, and we have tan inverse v over 2, right? Now let us replace v by x plus 1 over x, that is simply x square plus 1 over x. So here we have half, and tan inverse x square plus 1 over 2x, right? So the value of the integral I2 is half tan inverse x square plus 1 over 2x, right? So now we have obtained the values of I1 and I2, and here we can also take the constant of integration as C1 and C2, which can be added in the final step to get another constant of integration, that is C. So here we are not going to take C1 and C2. We'll finally write one constant of integration as C. So now substituting the values of I1 and I2 in this expression, we have now this result. And here we can now write the final constant of integration, that is C. So now I can further be written as we can take half common. So we can write 1 over 4 multiplying half and half, so we have 1 over 4, and here we have 1 over square root of 2, tan inverse x square minus 1 over 2x root 2, and here we have simply tan inverse x square plus 1 over 2x, and c is the constant of integration. So viewers, the value of this integral is given by this expression, right? And here we have seen that we can easily solve these kind of indefinite integrals by using the application of these three results along with the method of integration by substitution.